Hello and welcome to 6.2. We're talking about rates today. So your objective is that students will use rates to compare quantities. Okay, a rate is really just a ratio that compares two quantities, but they're measured in different units. Okay, so yesterday we talked about ratios that maybe compared number of students to number of students. Today we could be talking about a rate that compares number of students per cats or something. They have different units. Okay, a unit rate is just a rate whose denominator is 1. You'll need to know what the better by means. Here you're just going to find unit rates for the items and then compare to determine which one costs less. You really just want to know which one is going to be better use of your money. When finding the better by, you always want to know the price per item. This means you're going to put the cost in the numerator and the quantity in the denominator. So that's really important to note. Price per item. To change a rate to a unit rate, you're just going to divide both the numerator and denominator by the denominator. Okay, let's check out our first example. A Ferris wheel revolves 35 times in 105 minutes. How many minutes does one revolution take? Okay, so we want to find our unit rate. We want to find out when the denominator is 1 revolution. Okay, how many minutes does it take for 1 revolution? So again, a unit rate, you're going to write all your rates as fractions, and the unit rate just has a denominator of 1, which I did. Well, it gives us a rate of 105 minutes per 35 revolutions. So because I set up this rate here with revolutions in the denominator and minutes in the numerator, you should do the same with the rate that they gave you. So I put revolutions in the denominator, minutes in the numerator. Okay, and then on a previous slide it said to find the unit rate, you're just going to divide both by the denominator. And in this case, the denominator is 35, which makes sense because 35 divided by 35 is 1. And 105 divided by 35 is 3. And you are allowed to use calculators in this unit, so go ahead and use your calculator to do 105 divided by 35. So every 3 minutes it completes 1 revolution. And that's how I want you to write all of your answers, is in a fraction such as that. Okay, Sue walks 6 yards and passes 24 security lights set along the sidewalk. How many security lights does she pass in 1 yard? Again, I'm trying to find a unit rate. Unit rates have a denominator of 1. And in this case, I want to know per 1 yard. Okay, and we're talking about how many lights does she pass per 1 yard. So I'm going to set up the rate that they give me, 6 yards and 24 security lights, in that same manner. So I'm putting the yards in the denominator and I'm putting the lights in the numerator. So again, to find my unit rate, I'm just going to divide both by the denominator. 6 divided by 6 is 1. 24 divided by 6 is 4. So 4 lights in every 1 yard. That is my unit rate here. A dog walks 696 steps in 12 minutes. How many steps does the dog take in 1 minute? Okay, again, my denominator should be 1, and here the question asks us per 1 minute. Then we want to know how many steps per 1 minute. Okay, and the original rate they gave us was 696 steps in 12 minutes. Again, making sure your units stay consistent. Steps on top, minutes on bottom. So again, you're just going to divide both by your denominator. Divide by 12, divide by 12. Well, 12 divided by 12 is 1. 696 divided by 12, again, you are allowed to use your calculator, is 58. So we have 58 steps per 1 minute. Again, this is how I expect to see all of your answers, in fraction form with units. Danielle is cycling 68 miles as a fundraiser commitment. She wants to complete her ride in 4 hours. What should her average speed in miles per hour be? Okay, so I want to know her speed per 1 hour. Okay, what should her miles be in 1 hour? Unit rate. So I'm going to say, well, she's going to cycle 68 miles in 4 hours. At least that's her goal. Okay? So how many miles would that be per 1 hour? Well, if I just divide each by 4, 68 divided by 4 is 17. So she should go 17 miles in 1 hour in order to cycle those 68 miles in 4 hours. Rhett is a pilot and needs to fly 1,191 miles to the next city. He wants to complete his flight in 3 hours. What should be his average speed in miles per hour? So again, I want to know how many miles should he travel in 1 hour. Unit rate. Your denominator is always 1. So he goes 1,191 miles and he wants to complete that in 3 hours. So I'm going to divide both the numerator and denominator by the denominator. 1,191 divided by 3 is 397. So he should go 397 miles per 1 hour, or 397 miles per hour, in order to get there within 3 hours. Okay. This example is going to be a little bit different. We're still going to find unit rates, but we're just going to add an extra step at the end. So at summer camp, the campers are divided into groups. Each group has 16 campers and 2 cabins. How many cabins are needed for 112 campers? So I'm going to find the unit rate first of all to figure out how many campers per 1 cabin. Okay, I want to know how many campers are there going to be in 1 cabin. That will help me figure out how many cabins are needed for 112. Well, the rate that they gave me was 16 campers can fit into 2 cabins. Okay, again, to find your unit rate, divide each by the denominator. Okay, 2 divided by 2 is 1, 16 divided by 2 is 8. So you're telling me 8 campers per 1 cabin. Okay, so I'm going to rewrite that. 8 campers for every 1 cabin. So what if I have 112 campers? Okay, how many cabins would I need? Well, to get from 8 to 112, you have to multiply by 14. Okay, and what you do to the top, you should do to the bottom. And 1 times 14 is 14. So if you're going to have 112 campers, you're going to need 14 cabins. 14 cabins. So find the strategy for this one is to find your unit rate, and that unit rate is going to allow you to set up a pretty much equivalent fractions to find out the missing information that you need. Okay. Pete jogs 3 miles in 27 minutes. At this rate, how long would it take him to jog 5 miles? So again, your strategy here should be to find the unit rate first. Okay, so I want to know how many minutes does it take him to jog 1 mile? Okay, that would help me figure out how many minutes it takes him to jog 5 miles, right? So how many minutes per 1 mile? Well, the rate that they give me is 27 minutes in 3 miles. Okay, so I'm going to divide each by 3. So 9 minutes, it will take him to do 1 mile. So 9 minutes per 1 mile. Okay, and that will tell me, well, if he wants to go 5 miles, how many minutes will that take him? Okay, some of you would say, well, I'm just going to maybe add up 9 plus 9 plus 9 plus 9 plus 9 because I know he's traveling 5 miles and each one takes 9 minutes. But it'd be a lot easier just to go ahead and multiply each by 5, and 9 times 5 is 45. So it's going to take him 45 minutes to go 5 miles. So find your unit rate, and your unit rate is going to help you find your missing piece of information. Okay, you can set up equivalent fractions. Okay, here is a better buy example. A 12-ounce sports drink costs 99 cents and a 16-ounce sports drink costs $1.19. Which size is the best buy? Now, if you look back from one of the very first slides, I said that better buy, you are always going to take the cost and divide it by the quantity. Okay, so I'm going to have two different unit rates that I'm finding. One is going to be for the 12-ounce drink and one is going to be for the 16-ounce drink. So here I'm going to have the 12-ounce. Here I'll have the 16-ounce. And ounce is abbreviated OZ. Okay, so I'm going to take the cost for the 12-ounce, which is 99 cents. And I'm going to divide it by the quantity, or in this case, the number of ounces, which is 12 ounces. Okay, and a calculator would be handy at this point. We're going to take 99 cents and divide it by 12. I find that it is going to cost about let's see, this is in dollars, about 8 cents per 1 ounce. Okay, which isn't bad. I'm going to do the same thing with a 16 ounce. $1.19 divided by 16 ounces. Okay, so again, how much is that per 1 ounce? Well, $1.19 divided by 16 is about, looks like 7 cents. Okay, so 7 cents per 1 ounce. So which is the better buy? The 12 ounce or the 16 ounce? Well, it's actually cheaper to purchase the 16 ounce because you're only paying 7 cents an ounce versus 8 cents an ounce. So 16 ounce is the better buy. Okay, Sarah can buy 10 pencils for $4 or 6 pencils for $2.70. Which is the better buy? Again, we're taking our cost and we're dividing it by our quantity. So here I'm going to do the 10 pencil pack, and here I'll do the 6 pencil pack. Okay, pencils. Okay, so I'm going to take the cost of $4 for the 10 pencils and divide it by 10 pencils. So the cost per 1 pencil is 4 divided by 10 is 40 cents. It's 0.4, or in other words, 40 cents per pencil. And the cost of 6 pencils was $2.70. I'm going to divide that by the number that there is. Oh, this is pencils. I'm just going to abbreviate that. So for 1 pencil, again, I'm going to take 270 divided by 6, and that's going to cost 45 cents per pencil. So your better buy in this case, it is cheaper to actually buy the 10 pencil pack because you're only paying 40 cents per 1 pencil versus here you're paying 45 cents per pencil. So go with the cheaper option. The 10 pencil pack is actually the better buy. Okay, and your homework, of course, will be the 6.2 worksheet.